Alright, so this is video 3 for section, hang on. Alright, for chapter 2, module 2. This is part 3 of the videos. You've had the first 2. Alright, today we're talking about horizontal, vertical, parallel, and perpendicular lines, and we're going to start out talking about horizontal and vertical lines. So, of course, on the coordinate plane, a horizontal line goes left to right. Okay, it's flat, so it has no slope. So if you were to think about the linear equation y equals mx plus b in slope-intercept form for a horizontal line, well, if it's flat, we know that's a constant function, and we know that a constant function has 0 rate of change, or a slope of 0. If you put in a 0 right here, you would have y equals 0x plus b. 0 times x is gone. So in a horizontal function, or horizontal line, because your slope is 0, you don't have an x term in your equation. You just have your y term equal to the y-intercept, which is where it crosses the y-axis. So if this was at positive 4, then the equation for this line would be y equals 4. There's no x term, again, because there is no slope. The slope is 0. All right, a vertical line, however, travels in a vertical direction. All right, a vertical line is the opposite of that. Because it travels in a vertical direction, it's never going to cross the y-axis. Everybody see this? So there is no y-intercept. So y equals mx plus b. The y-intercept is always 0 because it never crosses this y-axis anywhere. It never touches the y at all. Also, the slope here is undefined. So the slope doesn't work. This entire equation right here really doesn't work. Slope-intercept form does not work for a vertical line. A vertical line crosses through the x-axis, so it has an x-intercept, and so therefore your equation for your line is x equal in whatever that intercept is. So let's say that it's at 5, then the equation for this line is x equals 5. So, because a horizontal line goes through the y-axis at an intercept, the equation is y equals and that intercept. Because a vertical line goes through the x-axis at a certain point, the line is x equals whatever that intercept is. So let's find the equations of the vertical and horizontal lines passing through the point 8, 5. So if you think about it, if we go to 8, 5, 8 is going to be somewhere down here, 5 is going to be up here, so our line is right here, our point. If we drew a horizontal line going through that point, that would be this way, it would cross through the y-axis at this point 5, so therefore the horizontal, excuse me, I said the wrong thing, the horizontal line going through 8, 5 would be at y equals 5 because it crosses through the y-axis. The vertical line crossing through 8, 5 would go this direction vertically, and it would cross through at the x-axis with an x-intercept at the point x equals 8. So therefore the equation for that vertical line is x equals 8. Okay, so that's the basics of horizontal and vertical lines. Now let's talk about parallel lines. Two lines are parallel if they have the same slope. So if I gave you the line y equals 5x plus 8, well then the slope for that line is 5. Hold on.
Windsor to Civil Services. Chantalethia Windsor to Civil Services.
Alright, so the slope for that line would be 5. Well, if I wanted to have another line that was parallel to that line, then it would also have to have a slope of 5, but it could have a different y-intercept, so it could be plus 12. So as long as the slopes are the same, then those lines are parallel, meaning they run side by side, but they never touch. So, this example, find the equation of the line parallel to y equals negative 2x plus 5 that passes through the point 4, 3. So first, let's start right here. The slope of that line is negative 2. Well, if I want to be parallel, then my slope must also be negative 2. So I need my slope to be negative 2, and I want it to go through the point 4, 3. So in this particular problem, I know a slope and I know the point, which tells me I'm going to use point slope form. So from video 1, we learned point slope form, which is y minus y sub 1. equals m times x minus x sub 1, and we're going to plug in our point. So we have y minus our y sub 1 is 3 equals m times, I'm sorry, we know m. Let me try that again. All right, m is negative 2 times x minus, and our x sub 1 is 4. All right, so now we're at this point in most problems, they'll tell you what to do. Like they'll say, find the equation and put it in standard form, or find the equation and put it in slope-intercept form. This problem, they didn't tell us what to do, so that means you can do whatever you want. So since most of you like it better, I'll go to slope-intercept form. So I'm going to distribute. I'm going to get y minus 3 equals negative 2x plus 8. I'm going to move that 3 over, so I'm going to add that 3 to both sides. And I'm going to get y equals negative 2x plus 11. This is slope-intercept form. If they asked for it in standard form, then I would move that negative 2x back to the front and make it positive 2x plus y equals 11. So pay attention to your directions, give your answer and what they ask for. If they don't ask for anything specific, you can do whatever you would like. All right, so let's review perpendicular lines. Two lines are perpendicular if they have slopes that are opposites and reciprocals of each other. So let's look at that. What if I gave you a line that had a slope of 1/4 x? And I asked you to find a line that was perpendicular. Well, it's perpendicular if you take the slope here is 1/4, and you find the opposite. That means change the sign. So since this one's positive, my slope is going to be negative. And then reciprocal means flip it upside down. So 1/4 flips upside down and becomes 4. So I have 4x. Again, your y-intercept can be any y-intercept that you want. It's the slope that makes them be perpendicular. So a 1/4 and negative 4 are opposite reciprocals. So let's do the next example. Find the slope-intercept form of the line perpendicular to y equals negative 2/3 x plus 2 that passes through the point negative 2 and 1. So first, let's start right here with that slope, and we know we want to be perpendicular. So in order to be perpendicular to that slope, I know that I must take the opposite. Well, it is negative, so I'm going to be positive. And it's 2/3, so I'm going to flip it upside down and become 3/2, a positive 3/2. So I know the slope, and I know I want to go through the point negative 2, 1. I have my slope, and I have my point, so I'm going to use point slope form. So we have y minus y sub 1 equals m times x minus x sub 1. And we plug in our numbers. So we have y minus our y sub 1 right here is 1. We have our slope, which is 3/2. Times x minus, and our x sub 1 is negative 2. That negative makes this become a positive 2. All right, they did tell us this time that they wanted it in slope-intercept form. So I'll go ahead and do that. So we have y minus 1 equals 3/2 times x. I'm distributing here. And 3/2 times 2 is 3, because the 2 cancels with the 2 on the bottom. I'm going to add 1 to both sides. And I'm going to get y equals 3/2 x plus 4. And that's in slope-intercept form. And that's the end of this video.